Hi friends, welcome to follow up. Let's have a look at an easy problem, problem 2810, faulty keyboard. So in this video, our goal is to first write a verbose solution, and then we do a slight optimization. So here we have a laptop keyboard, which is problematic, and whenever we tap a character I on it, and it will reverse the string that we have written. So typing other characters works as expected. So here we are given a zero index string s, and we tap each character s using our faulty keyboard. So we want to return the final string that will be present on our laptop screen. So here are two examples. So in the first example, so we can tap s, tr, then if we look at, we met another I, so it's going to have RTS, reverse the prefix, and then we tap N and G. So what we are going to have is RTS, the reversed prefix, and then followed by NG. So this is the first example. Well, for the second example, here it appears there are two I's, so the prefix actually does not change, right? So we are going to have PO, and then followed by the characters after the two I's. So this is example 2. So here the constraints are the following. First, the string has a very limited length, so it can be greater than or equal to 1, but has an upper bound, which is 100, right? So if the upper bound can be very large, so we need to think a little bit more, right? So here S consists of lowercase English letters, and S not does not equal to I. Just some consistency assumption. So with that said, actually, also due to the easy nature of this problem, so we are going to directly look at the code. So here the observation is that, so if there are even count of consecutive I's, actually the corresponding prefix is unchanged, right? If odd number of count of I's in consecutive order, so the prefix will be reversed. So this is our main observation for this problem. So we can do it verbosely, and we can also do it with slightly complexity. First, I'm going to present one which is very verbose. So for this, I'm going to initialize a empty list, and then we're going to scan this string s. So for character in s, right? So if character is not I, so in this case we just do an append operation, right? We append the character into the aux list. Otherwise, what we are going to do, we are going to reset the aux state. It's in the reverse of the previous one. And then afterwards, what we want to do actually is nothing but join the aux list to get the result, right? So this is the one format of solution. So let's first make a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So here actually it's possible, like in this example. So we have 3 I's in the row. So actually this we are only interested in the number of I's. So here this is an odd number. So we just need to reverse the prefix str, right? If we have 4 I's, we just keep that. So in other words, we don't need to do a reverse for each appearance of I. We just count the evenness or oddness of the I's. So with that said, let's look at the second version of solution. So this one actually is verbose, but it's sufficient for this problem due to the assumption that the length is bounded above by 100. What about if the length can be as long as 10 to the power 5th, for example? So we need to improve a little bit. So let me copy this part, this one, let's see, and then we modify a little bit. So what we want to do, we are going to introduce another variable as a count. So we want to count the consecutive number of I's, right? So basically for this, I want to iterate. So here, this I is indexed, right? Not the character I. So for I, character in enumerate s, what we want to do is we check if character does not equals I, right? So in this case, because it's not I, so what we are going to do is to check if we are actually need to change the previous one, because after we can think of like this. So we have first we have eyes, and then we look at this character, it's not I anymore. So in this case, what we want to do, we will check the count, and then we check the evenness or oddness. If it's not 0, right, we need to do a reverse. So do this aux reverse. This is the one. And otherwise, in this case, after we do this, we are going to reset the count variable to be 0. And this is the one case. Otherwise, so if it's not I, we need to append, right? So aux append character. So this is the one block. The other block is that, so if the character continue to be I, so we want to increment the count of this consecutive I's by 1. And in this case, we want to pay attention to if the I is the last I appearing in the string. For example, in the tail that has several I's. So in this case, we want to check if I equals length of s minus 1 and count over 2 is not 0. In other words, it equals 1. So in this case, we need to do a reverse. So this is important to notice, right? Don't forget this case. And otherwise, afterwards, so we just need to do the join operation again. So here, we introduced a count variable which is used to count consecutive I's. For example, here we have 3 I's, so we need to reverse this just once, right? And if we have 4 I's, we don't need to reverse. So this is the role of this variable count. And basically, once we meet a non-I character, we check if we need to do the reverse, and then we append the character. If we continue meeting I's, we are going to increment, but we need to pay attention. If the I is the last one, we need to check if we need to do a reverse or not. So with that said, this finishes the second version of solution. Let's do a test. Invalid syntax if I equals, okay, so here is I minus 1. So let's do a test. Yeah, it passes this example. Now let's look at the generic case. So yeah, it also passes all the cases. So with that said, that's about it for this specific problem. Thank you.